inductive effect. And to discuss about inductive effect, and we have found it is of two types. One is minus I effect, another one is plus I effect. That is, if the carbon compounds are containing electronegative element or electron withdrawing group, they pull the electron from the carbon. They pull electron from the carbon and makes them electron deficient. And in order to compensate, they go on pulling the electron to the chain. By that way, the electron deficiency property occurs. And after third carbon atom, generally we find the effect is not visible. And this one we call it minus I effect. Okay. So this is a electronegative element or electron withdrawing or attracting group. And electronegative element means the halogen, fluorine, chlorine, bromine, iodine, an electron withdrawing group in the form of nitro, nitroso, aldehyde, ketone, carboxylic acid, star, amides, cyanide, etc. So this is minor effect. And for plus effect, say if they are being substituted by an electron donating group, that is, they should have lone pair. In this case, what do you find? This is due to electron pair repulsion. Electrons are being pushed towards the carbon side. Okay? They have become like this. Okay, so this is electron rich species. So this is called plus I effect. Okay, and as a whole, we have found inductive effect is nothing but the displacement of sigma electrons along a sigma bond. But very interesting thing is that in this case, the electron which is present in this bond, they remain within the bond. From here it shifts here. From here it shifts here. All right, but they never cross the bond. Second one, we what you find the resonance effect. In resonance effect, what do you find? In that case, we find pi electrons or electron of the p orbitals, they undergo delocalization. What is the meaning of delocalization? It is they move from one atom to the other. That is, they will cross over, they will go over the double bond. Okay. So again, here also you find it can be of two types. Minus R effect and we get here plus R. So minus R effect are caused by the electron negative elements or electron withdrawing groups. And the plus R effect is caused by the electron donating groups. So I have given you an example of the minus R effect that day with the nitrobenzene. And plus R effect I have done with the resonance of the phenol. Okay. So that day I have shown you with the nitrobenzene. All right. Say, okay, I'm going to doing example here again. That day I have done with nitrobenzene. I'll do it with something else. I thought you may not understand. Again, okay, I'll show you the first nitrobenzene, then I'll give you some others. That day we have done this one. This is the structure of nitrobenzene. See here, this electron moves here because oxygen is more electronegative. Moment you pull the electron, this nitrogen become electron deficient. So this nitrogen pulls the electron from here. See now, in this case, nitrogen from this carbon it goes this carbon to this nitrogen. Okay. So that here the valency of nitrogen is 4, here it is also 4. Now this this electron, see here, bond consists of one electron here and one electron here. This electron has gone here. What has happened now? In this case, this carbon becomes electron deficient. Now from here this electron goes. So you will get this electron goes. So this carbon will become electron deficient. Then this will come here. This is the one. Then after that, oxygen sends back the electron. Again this comes. And here you get the original. This is minus R stands for resonance. Now for plus R, that they have done resonance structure with phenol, I'll do it today with aniline.
Page up the 10. See here. This will come here. This electron will come here. Moment this comes due to repulsion, this electron moves. Because electron repel. Yes, both of them have the negative charge. Then this electron comes. Moment this electron comes here, this electron get repelled and comes here. Then this comes here, immediately this goes here. So you'll get it here. Finally, this comes here. And here you will get this. This is plus R. Please draw.
So we have seen in case of the carbocation, tertiary is more stable than
I'm not talking about benzyl halide. See here, why it is like this? See, here alkyl groups are electron donating in nature. So, in this carbon, which is electron deficient, which has lost electron, see there are 3 alkyl groups to supply electron. So it could overcome the electron deficiency. Suppose, say you have you have gone somewhere and on the way you lost your parts. You feel very insecure that how will you come back? But if you find along with you there are 3 friends are very good friends are there that told you don't worry, we are there to help you. Then you feel a lot of comfort. So in this case you have 2 alkyl groups. Okay, it has only 1, and it has no alkyl group because hydrogen neither can attract electron nor can donate electron. So in this case, because of this plus I inductive effect, this is the stability of the carbocation. See, these are all theoretical things, but when we have done the experiment, we found our theories are perfectly correct. So this is the order of stability of the tertiary, secondary, primary carbocations. And we find the methyl carboncation is least stable. Okay. So stability is because of what? The stability of this carbocation is due to plus I effect of electron donating alkyl groups. In case of carbon ion, we find it is just opposite. See here. See, this carbon is electron rich. So when three alkyl group starts supplying electron, there is huge repulsion takes place. And due to that, it becomes least stable. Supplying of electron is just like, as I told you in case of the carbocation, say you are having some problem and your friends are supporting you. But take the, in this case, suppose you are being constantly irritated by three persons, then you will feel very, very discomfort. Similar is the repulsion. See here, is already having electron, three alkyl groups are supplying electron. The huge repulsion takes place that makes it extremely unstable. Here you have two, here you have one, but here you do not have any group to supply electrons. So this is the most stable. Okay, now what we can write here? The stability of the carbon ion decreases due to increased repulsion between the negative charge on carbon atom and electron donating alkyl groups.
Done, sir.
So you could understand. But one thing we have found, in all the three series that I have drawn for you, written for you, there you have found that benzyl cation is more stable, or benzene anion is more stable. See, in case of the carbocation, we have found the series from here is totally different. In case of carbocation, this is the most stable and this is the least stable. In case of carbanion, this is most stable and this is least stable. But in both the cases that you have written, you have found whether it's a cation, anion, or free radical, benzyl is most stable, followed by Li. Why it is like this? So that I cannot explain it with the help of inductive effect. That I can explain only by the resonance. Okay. So let me write here. Role of resonance. In stability of benzyl and allyl carbocation and carbanion. यही मतलब है Okay, now see here. Benzyl, see here. Let me write benzyl cation as like this. See here. This immediate electron from here supplies it. See. See. So this is stable because of the circulation of electron within the cation. This is what type of resonance? See, when the electron goes out of the ring, we call it minus R effect. Okay. Then comes allyl. Allyl. See here. This is allyl cation. What happens? Let's see, one electron is here, one electron is here. This electron immediately goes here. to this. So this cation gets stability okay. No, I know write like this. Here I write. Benzyl cation is stable because of minus R resonance effect. Now we go for benzyl carbonyl. See here. In this case, what will happen? This electron will come. So what should I write now here? See, electron is supplied, so it is called plus other electron. Here you have the negative charge, so it will be like this. Then it will go back. What will happen now here? This. না এটা আমি ফালাইও না, আমি ওখান থেকে কলমটা মধ্যে কলম রাখতে পারবো, মিলিয়ে রাখছি, এটা দইয়ে রাখুন। ওই যে একটা ছোট কাগজের বক্সটার মধ্যে একদম ক্রাউডেড ঢাকা আছে না, কলম ধুলাবালি রাখলেই তো না একদিনও আছে। Now see, I'll tell something for your entrance exam. See, more the number of the resonance structures, more stable the carbocation is or carbanion is. Resonance structures are called canonical structures. More the number of resonance structure or canonical structure, more stable the carbocation or carbanion is. See, that I already told you that among the benzyl we have see, this is triphenyl. See, if this one carbon is methyl, triphenyl, methyl, carbocation is more stable. Than this. This is called phenyl. This is called phenyl. See, only one is there. Methyl. Or what is the other name? What is the common name? Benzyl. Why it is more stable? See, we have already drawn the resonance structure of benzyl cation. There are 5 resonance structures are there. In this case, because of 3 phenyl, all this phenyl repeatedly they go for resonance stable. So here I'll write. This is okay. Now this also has a name. We call it trityl. This is common name. This is most stable carbocation. Why? It has 36 number of canonical structure. Remember. And very few of you are attending the classes. I do not know why. Hello, Gitanjali.
Yes, sir.
Pinaki, Bangalore?
Yes, sir.
Huh?
Yes.
Another term we call it hyperconjugation. See, what is the meaning of conjugation? Conjugation means alternative. See here. When we have done the, just now we have done. See here. Here, this double bond between this double bond and the carbocation, one single bond is there. So this is called alternative or conjugation. Or suppose we have done the resonance of this one that they have shown you. See here, between these two double bond, one single bond is there. So we call it conjugated double bond. Conjugation means alternate. Now, what is hyperconjugation effect? Hyperconjugation effect. Okay. See, in case of inductive effect, we find these sigma electrons get displaced along the sigma bonds. Okay. It is one sigma electron pushes the other sigma electron. In resonance, what do you find? That it is the pi electron or the electron of the p orbital move to another pi bond or p orbital. So it is a matter within them. It is, in case of inductive effect, it is within the sigma bond. In case of the resonance, it is the movement of the pi electrons to another pi orbital or p orbital. In case of hyperconjugation effect, we find sigma electron goes to the pi orbital or p orbital. So it is a mixing of both. Sigma electron interferes with the pi electron. So again I'm telling you, it is inductive effect. It is purely within the sigma electrons. In case of resonance, it is purely with the pi electrons. But hyperconjugation is the mixture of both of them. It is the sigma electron moves to a pi orbital, or we know pi orbitals are being formed by p orbital. Okay, so it goes to a empty p orbital. So it is something unusual. So anything which is unusual, we call it hyper. See, the normal blood pressure of human being supposed to be 120 by 80, systolic and diastolic. But if you find, after they are measuring of pressure, it happens in every family. Any of you may find your grandfather, grandmother, or your parents. They, in that case, when they measure the blood pressure, suppose 120 has become 160 or 170, and the lower one has become 100, then doctor says that you are suffering from hypertension or high blood pressure. Okay, so something is initial. So let us first write down what is the definition of the hyperconjugation. Okay,
right here. It is the delocalization. Delocalization means what?
that is getting shifted.
It is the delocalization of sigma electrons into pi orbital or empty p orbital.
So this is called hyperconjugation.
So let me show you. Say I'm going for this. This is called tertiary butyl carbocation. This is tertiary cation. Okay, so let me first write down it like this. So it is this. I'm expanding on this side. This is this. Yes. Okay, look here. In this bond, you have 2 electrons are there. If it happens, see, between carbon and hydrogen, carbon is more electronic. So it may happen this bond breaks. Carbon has taken the electron of hydrogen. So what you will get now here? You will get
See, this electron of this is the electron of carbon, this is the electron of hydrogen. Okay. So see, the hydrogen is side by side. It remains side by side. See. So this is the carbon which is having an empty p orbital. What will happen now? This electron will go to here. So it will remain. So it will, hydrogen will remain. All right. Now what will happen again? This hydrogen has not gone anywhere. Then after that again it breaks. What will happen now here? This. See again it has come back. Electron has come back. Okay. Again this electron will go to the hydrogen. And you will get this. Don't write. See. Like this. So what has happened? See here, this is the sigma electron. This sigma electron goes to the empty p orbital. And you get this. Again it comes back, again you get back the same. Okay. So now, as because again it comes back, so we should put it in double L. Because the structure again you get. So these are interconvertible. Okay, now see. Once it comes back, first we started with this hydrogen. Then this hydrogen will participate. This will participate. Similarly, here you have 3 hydrogen. These 3 hydrogen in by turn will participate, and 3 hydrogen by turn will participate. So how many hyperconjugation effect it shows? So it shows 9 hyperconjugation effect. So in this case, what did you do? So in this case, sigma electron of carbon hydrogen bond delocalize to the empty p orbital of carbon containing positive charge. Draw. So if I have taken See, so this has 9 hyper conjugation. What is this? This is called tertiary. If I have done for this, this is secondary. See, 3 here, 3 here, 6. 6 hyper conjugation effect. See, this is primary. It is only 3. 3 hyper conjugation effect. Okay. Look. See. Here, no, this carbon does not have any methyl group. So now no hyper conjugation. See, earlier I have explained the stability of the carbocation through plus inductive effect. Now we find that carbocation is also stable because of hyperconjugation effect. So stability of this tertiary carbocation is because of 2 reasons. One is the plus inductive effect of 3 alkyl electron-loading alkyl groups as well as hyperconjugation effect. We'll go for the, here what did I write? In this 6 sigma electron of CH bond delocalized into empty p orbitals of carbon containing positive. Now we'll go for delocalization into the pi orbitals. Okay. So let me now take here see, this we know as propene. Now see. Okay. So here you have 1 electron and here you have 1 electron. This electron comes here, what you get? You get this. And hydrogen will be nearby. Now we know it will show resonance. So what is going to happen now here? See, this electron has gone here. We'll put negative charge here. All right. So generally, when you put one, see, this electron belongs to this carbon. When extra electron comes, then it acquires a negative charge. So we'll write here now negative. So see, then I have to write here positive because this electron has gone here. See now what will happen? This electron will come here. So you will get here. This and this H plus is nearby. This H plus is. Then what will happen? Again it will come back. You will get here now. Then again you will come back. So what will you get now here? Wait, what did I make any mistake? It will come here. No, dear. No, I made a mistake. Yes. So once it comes, negative charge is here, positive charge is here. Again, it will come back. You get here. This. Then it will go. So you will get here. See. Again, you get it. So here, this is sigma electron. Sigma electron mixes with the p orbital, pi orbital. So what we will write now here? In this molecule, sigma electron of CH bond delocalizes into pi orbital. Toluene. Toluene is what? Methyl. What is this?
also show hyper conjugation